Different methods of food processing following the industry standard. Sugar concentration, fermentation and pickling. Content standards. The learners demonstrate an understanding of the concepts and skills in food processing. Performance standards. The learners perform recipe quantification in food processing and develop label design for processed products. Learning competency. Discuss different methods in food processing following industry standards. Learning objectives. Identify and describe food processing methods, sugar concentration, fermentation, and pickling. Explain the purposes, benefits, and preservation science behind these methods. Demonstrate engagement by answering questions and observing video clips of the processes. Short review. Directions. Choose the letter of the correct answer. 1. It is a substance added to food to enhance flavor, complement dishes, or add moisture. They often include sauces, spreads, or seasonings. A. Herbs and spices. C. Food additives. B. Condiments. 2. Plant-derived ingredients used to flavor food. A. Herbs and spices. B. Condiments. C. Food additives. 3. Substances added to food during processing to improve flavor, texture, appearance, or shelf life. Preservatives are a subset of food additives specifically added to prevent spoilage and extend shelf life. A. Herbs and spices. B. Condiments. C. Food additives. 4. The following preservatives are a subset of food additives specifically added to prevent spoilage and extend shelf life except blank. A. Monosodium glutamate. B. Ascorbic acid. C. Cumin. 5. The following examples are herbs and spices except blank. A. Mustard. B. Basil. C. Ginger. Let's read the story about Fina's backyard harvest. Fina's backyard harvest. Fina loves planting fruits and vegetables in her backyard. She grows mangoes, tomatoes, and cucumbers. After harvesting, she noticed that some fruits and vegetables spoil quickly. To avoid wasting her harvest, she started experimenting with ways to keep them longer. She even shared some of her preserved fruits with her neighbors, who were happy to try them. What problems did Fina face with her harvest? How did Fina try to solve her problem? What do you think is our topic for today? Today's topic is different methods of food processing following the industry standard. Unlocking content vocabulary. Food processing is the process of transforming food items into a form that can be used. Changing raw food, like fruits, vegetables, or meat, into a form we can eat, store, or sell. Example: turning mangoes into dried mangoes. Fermentation is an enzyme-catalyzed, metabolic process whereby organisms convert starch or sugar to alcohol or an acid anaerobically releasing energy. A process where tiny organisms, like bacteria or yeast, break down sugar or starch without oxygen. This makes alcohol or acid and gives off a little energy. Example: making yogurt, kimchi, or bread. Pickling is the process of preserving food by either anaerobic fermentation in brine or immersion in vinegar. Preserving food by putting it in salty water, brine, or vinegar. Example: cucumber pickles or pickled mango. Curing means preserving the raw materials using different ingredients, seasonings and extenders. Keeping food from spoiling by adding salt, sugar, or spices. Example: salted eggs or cured ham. Worked. Example: sugar concentration, fermentation and pickling. Food processing means changing raw food into forms that are safer, tastier, or easier to store and eat. It can involve physical changes like cutting, cooking, drying, or canning. It can also use chemical methods like pickling or adding preservatives. Examples: making dried mangoes, canned sardines, bread, pickles, or salted eggs. Why it's done: to make food last longer, or preservation. To make it look and taste better. To make it more convenient to use. Note: some food processing can reduce nutrients or add chemicals that are not always healthy if eaten too much. Food processing is done for many reasons. To make food last longer means increases shelf life. To keep food safe means prevents spoilage and contamination. To make storage and transport easier means food can be delivered safely to markets. To make food more appealing means turns raw food into tasty and attractive products. To provide jobs means many people work in the food industry. When we process food, we must follow certain criteria to make sure it is safe, tasty, and has a longer shelf life. Foods can easily be invaded by pests, bacteria, or molds, and they also undergo biological changes, like ripening, fermentation, or spoilage. To prevent these and maintain quality, different processing methods are applied. The following methods are applied for the proper processing of food. 1. Sugar concentration. 2. Fermentation. 3. Pickling. 4. Salting. 5. Curing. 6. Smoking. 7. Drying. 8. Dehydration. 1. Sugar concentration. Preparing raw materials. Sorting and grading fruits. The product should not have physical defects, as these could be entrance doors for pathogens that cause rotting. Before making products like jams or jellies, fruits must be sorted and graded to make sure they are good quality. While the characteristics of good fruits vary for every type of produce, there are a number of attributes that indicate quality. Integrity of shape. The produce should not have physical defects, as these could be entrance doors for pathogens that cause rotting. No defects. Fruits should not have cuts, bruises, or damage. These can let germs enter and cause rotting. Uniformity. Each product in the batch should be uniform in size, form, and color. Same size and color. Fruits in one batch should look uniform, similar size, shape, and color. Freshness. The product should be harvested right on time to achieve maximum turgidity, color, flavor, and crispness. This can be ensured by asking for information from the supplier. Fruits must be harvested at the right time so they are crisp, colorful, and flavorful. Ripeness or maturity. Usually indicated by color and firmness, ripeness or maturity refers to the maximum edible quality of the fruit. Color and firmness are indicators of maturity. Fruits should be ripe enough to eat, usually shown by their color and firmness. Juiciness. Juice content in fruits is directly related to the ripeness of the fruit. Ripe fruits usually have more juice, which is important for processing. Flavor. This can be checked by measuring the total soluble solids with a refractometer. The sweetness can be checked using a tool called a refractometer. It measures sugar level. Quality points for good fruits. Good size and shape, not too small, not deformed. Good color, bright and even, shows ripeness. Fresh, harvested at the right time, not wilted. No bruising, no cuts or soft spots. Little to no soil, fruits should be clean. No pest damage, no holes or insect marks. Types of fruits and examples. Pome or hard fruit. Examples: apple and pear. Berry. Examples: blueberry, cranberry, and strawberry. Tropical. Examples: star fruit, dragon fruit, custard apple, sugar apple, longan, mango, and rambutan. Citrus examples: lemons, oranges, and limes. Drupe, stone fruit. Examples: peach, coconut, and plum. Preparing fruit and other ingredients for processing. A. Washing and cleaning fruits helps remove soil and chemical residues from produce. Removes soil, dirt, and chemical residues from fruits. B. Knife peeling is when fruits and vegetables are pressed against stationary or rotating blades to remove the skin. It is used for fruits with skin that can be easily removed with little damage. Removing the skin using blades. Best for fruits with skin that comes off easily without damaging the flesh. C. Slicing refers to cutting food into broad or flat, thin pieces. Cutting food into thin, flat pieces. D. Mincing is mainly done for size reduction and homogenization. Cutting food into very small pieces to make them uniform. E. Testing pectin content. Pectin is a jelly stabilizer naturally found in fruits. Pectin is a natural substance in fruits that helps jams and jellies become thick and stable. First, boil the fruit in water until it becomes thick. Second, take 1 teaspoon of the fruit juice and put it in a clean container. Let it cool. Next, add 3 tablespoons of denatured alcohol to the juice and gently shake. Lastly, leave it for 1 minute and then observe. Large, firm lump means fruit has high pectin, good for making jelly. Small, soft lump means fruit has low pectin, jelly may not set well. Sugar as a preservative. Sugar works like salt in preserving food. It pulls out water from food and microbes. Without water, microorganisms, germs, can't survive, so the food lasts longer. Adjusting sugar and acid in jams and jellies. Sugar activates pectin, breaking the pectin-water equilibrium and binding water, allowing pectin to form a gel. Sugar plus pectin plus acid is equals to gel, or jelly texture. Sugar binds water and helps pectin form a gel. Acid strengthens the pectin gel network. Pectin is naturally present in fruit, and the balance of sugar and acid should match the fruit's pectin content. Excess acid makes the gel unstable, while too little acid results in soft lumps. Too much sugar weakens the gel, making it watery. Based on the pectin test, sugar is added in the following proportions. A. If juice is rich in pectin, add 1 cup of refined sugar per cup of juice. B. If juice has moderate pectin content, add 3/4 cup sugar per cup of juice. C. If juice is poor in pectin, add 1/2 cup sugar per cup of juice. Large firm lumps means more sugar and less acid. Soft, small lumps means more acid and less sugar. Sugar concentrated products are jellies, jams, marmalades, preserves. Think of jelly as the clear one. It's made by boiling fruit to get just the juice, which is then turned into a super smooth, see-through gel. How it looks: transparent and shiny. When you take it out of the jar, it holds its shape perfectly and has a fun, wiggly texture. How it's made: fruit is boiled in water to release something called pectin, a natural gelling agent, and then the juice is strained out. Sugar is added to that juice to create the final, firm jelly. Jam is the chunky and pulpy one. It's made by cooking whole or crushed fruits with sugar. How it looks: it's not clear like jelly. Instead, you can see and feel the tiny bits of fruit pulp and fiber throughout. How it's made: the entire fruit, or crushed fruit, is cooked with sugar until it becomes thick and spreadable. This gives jam a richer, fuller flavor because you're using more of the fruit itself. You can even mix different fruits to create unique flavors. The best jams come from fruits that are fully ripe, because they have the best flavor and texture. Marmalades are like jellies with a twist. They're made from citrus fruits and contain thin, see-through strips of the fruit's peel mixed into the gel. This gives them a unique taste that's a perfect blend of bitter, sweet, and tangy. They have a smooth, firm, and quivery texture, similar to jelly. Think of preserves as the chunkiest and most fruity option. They're like jelly, but instead of just juice, they contain whole fruits or large, juicy pieces of fruit suspended in a thick syrup. This allows them to capture the fresh flavor of the fruit and give you a mouthful of fruit with every spoonful.
Take your PB&J sandwiches up a notch with homemade grape jam. First, you'll need 4 cups of washed seedless grapes. I used red grapes because that's what was available, but if you want that really deep purple color, go for Concord grapes. Just make sure they're seedless. Next is 3 cups of sugar, which I know seems like a lot, but since we aren't using any pectin, we need the sugar to achieve the right texture. Finally, add a little water to help dissolve the sugar. From here, it's just a matter of stirring everything together and cooking over medium-high heat until the sugar has dissolved and the grapes have started to soften. This will take around 20 minutes with frequent stirring. Now use a potato masher to crush the grapes. If you want a smoother texture, feel free to use an immersion blender to blend the grapes at this point. I personally prefer the rustic texture, but hey, you do you. Once you have the texture you want, continue cooking the jam, stirring frequently until it thickens and reaches 220 degrees Fahrenheit, also known as the gel stage. This means the jam will set when cooled instead of being runny like syrup. Once cooked, ladle the jam into clean jars. This recipe makes enough for 2 jars like this, then place a clean lid on top, screw it tight, and chill in the fridge for 1 to 2 hours or until set. Your jam can be stored in the fridge for up to 3 months to make your wildest peanut butter and jam sandwich dreams come true. And if you enjoyed this, click on one of these other great videos and subscribe for more amazing recipes.
Next method is fermentation. Have you ever tried a slice of sourdough bread? A spoonful of tangy yogurt? A sip of apple cider? All of these delicious foods are made possible by a process called fermentation. Fermentation is an enzyme-driven process where tiny organisms like bacteria and yeast turn sugar into alcohol or acid for energy, all without needing oxygen. Zymology is the scientific study of fermentation. Fermentation has different types. Homofermentation. Think of homo as meaning one or same. In this type of fermentation, the microorganisms are specialists. They produce only one main product. Example: lactic acid bacteria ferment sugar and produce only lactic acid. This is why things like yogurt and most types of cheese taste so consistently tangy. Heterofermentation. Now think of hetero as meaning different or multiple. In this type of fermentation, the microorganisms are multitaskers. They produce multiple products from the same sugar. Example. When making sourdough bread or kefir, the fermentation produces a mix of things like lactic acid, carbon dioxide gas, which makes bread rise, and even small amounts of alcohol. This is what gives these foods their complex flavors and textures. Homofermentation is a type of fermentation where microorganisms, usually lactic acid bacteria, produce mainly one end product. Process. The main pathway is glycolysis, Embden-Meyerhoff-Parnas pathway. Glucose is broken down into two molecules of lactic acid. No gas, like CO, or alcohol is produced in significant amounts. End product, almost exclusively lactic acid. Example microorganisms, Lactobacillus acidophilus, Streptococcus thermophilus. Heterofermentation is a type of fermentation where microorganisms produce multiple end products from the same sugar. Process. Uses the phosphoketolase pathway instead of glycolysis. Glucose is broken down into lactic acid, ethanol, or acetic acid, and carbon dioxide. This leads to a mix of products instead of just one. End products. Lactic acid plus carbon dioxide plus ethanol, or acetic acid. Example microorganisms, Lactobacillus brevis, Leuconostoc mesenteroides. Kefir is a fermented milk drink with a sour taste, made using a culture of yeasts and bacteria. 1. Lactic acid fermentation. Produces lactic acid from pyruvate via lactate dehydrogenase, generating NAD+ from NADH. Used by lactobacillus bacteria to make curd and by muscles during intense exercise, causing fatigue. NAD stands for nicotinamide adenine dinucleotide. 2. Alcohol fermentation. The end products are ethanol, alcohol, plus carbon dioxide, CO. Happens in yeast, which is why it's used in making beer, wine, and bread. First, pyruvic acid is changed into acetaldehyde plus carbon dioxide. Then, acetaldehyde is turned into ethanol. Enzymes involved, pyruvic acid decarboxylase and alcohol dehydrogenase. Brewing beer and wine. Baking, carbon dioxide makes bread rise, bioethanol production, as a renewable biofuel. 3. Acetic acid fermentation. The end product is acetic acid, vinegar. It is a two-step process. Yeast first turns sugar into alcohol, anaerobic, without oxygen. Then acetobacter bacteria convert that alcohol into vinegar, aerobic, with oxygen. Vinegar production, from fruits, grains, or ethanol solutions, pickling and food preservation. 4. Butyric acid fermentation. The end product is butyric acid. Done by Clostridium bacteria, which are found in soil and even inside the human colon. Important uses. Redding of jute, leather tanning, tobacco processing, but also happens in our gut where it helps fuel cells in the colon. Produces some ATP, adenosine triphosphate, energy, while breaking down fiber and other materials. Jute redding, loosening fibers for textile use, leather tanning. Tobacco processing, seen in rancid butter, unwanted fermentation. Fermentation is an ancient and adaptable process used by tiny living things like bacteria, prokaryotes, and yeast, eukaryotes, to get energy from sugar without needing oxygen. Bacteria often produce lactic acid, which makes foods like yogurt and sauerkraut tangy. Yeast produces alcohol and carbon dioxide, which helps make bread rise and brews beer. This simple, powerful process is one of the oldest on Earth and is still essential for many foods and products we use today. Fermentation, using specific microbes under controlled conditions, creates a variety of products. This process is key to making wine, beer, pickles, and yogurt. It also produces essential items like antibiotics and vitamins. Fermentation not only adds flavor and a sour taste to foods but also improves their nutritional value and makes them easier to digest. Why should we eat fermented foods? They're not just tasty, they're great for our bodies. Here are the benefits of consuming fermented food. Better digestion. The good bacteria in fermented foods act like tiny helpers, making it easier for our bodies to break down and absorb nutrients. Stronger immunity. These foods help keep our gut healthy, which is a big part of our immune system. A happy gut can better fight off sickness. Lactose-free friendly. The fermentation process breaks down lactose, a sugar in milk. This means people who have trouble digesting milk can often eat fermented dairy products like yogurt and kefir without a problem. A natural defense. Some fermented foods contain compounds that scientists are studying for their potential to help protect our bodies at a cellular level. Fermentation is super useful beyond just food. Besides making tasty things, fermentation is used to create methane gas, which can be used as a fuel source. This happens naturally in places like freshwater sediments, the mud at the bottom of lakes, and is also used on purpose in sewage treatment plants. In these plants, tiny organisms ferment waste and produce methane, which can then be captured and used for energy. It's a way of turning waste into a useful product.
Go and get right now. I've got a whole collection of different vegetables here, from cauliflower, carrots, baby corn, celery, asparagus, radish, green beans, chilies, and garlic. And these are just things I saw and bought, but you can throw in all sorts of vegetables. I'm going to wash and cut all these up into smaller bite-sized chunks, and I also added some chives, dill, and basil. I also added some mustard seeds and peppercorns. I'm going for about a 6% salt brine, so that's 6% of the weight of your water in salt. Dissolve all the salt into the water, and then I'm going to fill up our jar with our vegetables and then top it up with the salt brine. I let this sit at room temperature for a few days, and I made sure to burp it every day to prevent gas buildup. Or if you're using a clip top jar, you can use a strong elastic band to hold the lid down while also allowing the jar to burp itself. After the first few days, I'll taste it every so often until I like how tangy it is, then I'll move it into the fridge to store. And while these vegetables are quite firm when they're fresh, they soften up quite a lot when fermented like this, while still having a really satisfying crunch.
Have you ever wondered how pickles stay so crunchy and delicious? Pickling is a very old method of preserving food that started over 4,000 years ago. The process is simple. Food is preserved in a solution of either common salt or vinegar. This solution stops bad microbes from growing, keeping the food safe to eat for a long time. Eating pickles can also be good for you. They are great appetizers and can help with digestion by getting your stomach ready to break down food. When it comes to pickling, the quality of your raw materials is super important. Here's a breakdown of what makes them suitable. Salt. Any pure common salt will work, but it should be free from certain minerals. Lime can lower the vinegar's acidity, which is crucial for preservation. Iron can react with ingredients and cause the pickle to turn black. Magnesium salts can give the pickle a bitter taste. Using a good quality vinegar is a must. Vinegar. It should contain at least 4% acetic acid. Vinegar with a lower acid content isn't suitable for pickling because it won't preserve the food properly. Spices are all about adding flavor. The types you use depend on the fruit or vegetable and the taste you want to create. Common spices include cardamom, chilies, cinnamon, turmeric, clove, and mustard. Water. You should only use potable water, water that is safe to drink. If you have to use hard water, add a little vinegar to the brine to help balance its alkalinity. Coloring and hardening agents. Generally, colors aren't added to pickles, though they might be used in some sauces. Some pickle makers use alum to help make the pickles firmer and crispier. Common fruits and vegetables used in pickling. Raw mango, lemon, amla, green chilies, garlic, onion, cauliflower, tomato, plums, grapes, apples, papaya, beetroot, boiled beans, cucumber, cabbage, radish, ginger,